what we learned before is all we have positive indices and so what we will learn is all integers, okay, negative integers or positive integers. So what is a rational indices? So we can see that's a fraction. Okay, we have a fraction on the index. So x to the power of 2 on 3, something like that. So numbers written with fraction indices can also be written in a root sign, okay, in a root sign. We can have a look. So a to the power of 1 over m, what that means? That means mth root of a, okay, mth root of a. So give your example, 3 to the power of 1 on 4. Okay, 3 to the power of 1 on 4. The root, the denominator is the order of the root. So that is a 4th root. And then we put the 3 inside. That's the rational, what the rational indices means. That's in the case we have a 1 on top. Okay, we have a 1 on top. Then if we have a number on top, let's say a to the power of m over n. So let's say 4 to the power of 3 on 5. So what the denominator will do, what the denominator will do is a 5th root. Okay, that's a 5th root. But what the numerator 3 will do, that will give a power. That's 4 to the power of 3. Okay, so that gives the number a power. So the numerator will give a power and the denominator is a root, like m's root. But we can also write this in the way we take the root first, okay, the 5th root first, and then everything to a power of 3. I can add the power the number first and then take the root, or I can take the root first and then power the result. What I would recommend is I would recommend this method. Why? Think about if you power something, that can make the number become a really large number. Right? Like 4 to the power of 3 become really large. And then you're trying to think, oh, I want to take the 5th root. Then I need to find how many repeated factors do we have in a really large number. That's very hard to achieve. So we rather do the root first. We can make it into a smaller number. And then we power that to make like reasonably easy to calculate compared to power it. So but like sometimes it's not really matters. For example, this question doesn't really matter because even though you took the power for the 4 root 5, you can't evaluate that. Like there's no answer for that. Like that's the exact form. You can't simplify any further. So we can't do anything. But if we think about this one, okay, if we think about the middle one, we can actually do something. We can actually do something. 4 to the power of 3. Okay, what is 4? 4 is 2 times 2, right? 4 is 2 times 2. And then you power of 3. How many 2's are there now? How many 2's are there? 6. Okay, 6 2. So what we will have here is 2 times 2 times 2 times 2 times 2 times 2. And then we take a 5th root. So this means we have 2 for 6 times. I want to take a 5th root. So 5 of them can come outside, become a 2. And that's 2 times 5th root of 2. It's like square root. Think about square root. If you have 2 repeated factors, one of that will come out. Like 3 times 3, 9 is 3 times 3. So when you take the square root, the 3 will come out. So a 5th root means the same. So 5 number, same number times together will give you the number inside. So now you have made the prime factor. You can see 6 2 here. So 5 of them can be simplified to take 1 out, become 1 2. And then we leave one of the 2 within the root. So I can actually simplify it by using this way rather than that way. Okay, simplify it, use this way rather than that way. Easier, yes?
How did you only get 1 2 when you wrote the actual?
Sorry?
Why is there only 1 2?
Just only one.
The other one.
Here. Oh, because again, 2 times 2 times 2 times 2 is 32, right? 32 take the 5th root is 2. So the question is same as, again, if I can say, I want to take the 5th root of 32, okay? So that's the same question as the both one. And then let's say that equals to x. Okay, that's the same as x to the power 5 equals to 32. So 5x times together give you 32. So what the x will be? 2. So that's why only 1 2 come out, not going to be 5 2 come out. Yeah, it's same as square root. Square root 9 equals to what? Square root 9 is 3 times 3. You have 2 repeat factors. So one of that will come out to get rid of the square root. Yeah. So when you see nth root, you just look at, is there nth repeated factor here? And if you have nth one, you take one of that out from the root. You take only one out. Okay? So that's how we work on the rational indices. That's how we work on the rational indices. Also, all the index law 1 to 5 will still work. Okay, so what the index law we learned last lesson? If we go back to the previous couple of pages here. Okay, for example, if you have the same base, you will add the power. We have different same base, you divide them, you subtract the power. So this still works for rational numbers. If m is rational, n is rational, it still works in the same way. So if we have a to the power of a half times a to the power of a third, you basically same base, you just add the power, so that power becomes 5/6. So you use a half plus a third. Doesn't matter whether it's positive number or negative number or fractional number, you always add them like in this rule. And then when you divide them, you always subtract the power when they have the same base. And when you have something, a power with another power, you times the power. So we don't really mind like it's what kind of number is that, but this rule is always true. Okay, this rule is always true. Okay, the negative indices one is very tricky now. Okay, so what is 4 to the power of -2? What is this? You want to evaluate that? 1 over 4 squared, that's right. 1 over 4 squared. So that's 1/16. Now, if you have a rational number here, like for example, -1/2. Well, let's take an even complex one. If you have a more complex one, for example, 5 over -2/3, something like this. So the negative, okay, remember the negative is always do as 1 over something. Always do as 1 over something. So this one can be written in the way 1 over 5 to the power of 2/3. Okay, just an example. So the negative is 1 over. Just get rid of the negative, you need to go 1 over. And whatever left, you just copy that. And then this will be 1 over 5 to the power of 2, and then take a cube root. So the denominator will become a third number. Okay, third number. So it's 1 over, and then the root. Okay, and the root. So 2 is the power, and the denominator is the nth root. So it's the cube root, and like the third root. Okay, let's have a look at some examples, which is quite interesting to think about. If you can have a look at numerator. So this I can write x to the power of 2 over 5. So that is the power form. So this is the third form, what is given, and then what you can do is into the power form, index form. And the power is the numerator, and the third is the root, is the denominator. Okay, next one. What is the power in this case? Do you think that's a 2/6? Anyone disagree? Yes, Michelle?
We tend to split the brackets power of the student.
Yes. the 2, you can't do the power as 2 over 6 because can you see 10 is not get powered. Like the power 2 is not power everything in the under the denominator. In the third, it only square the t value. So if you really want to do a 2 over 6, what you can do? Well, I will just go for the easy way first. So that's everything under the root, then to the power of 1 on 6. That's one way you can write it. Okay, that's one way you can write it. You can see the 2 can't go out because 10 is not get powered. So you can't do the 2 over 16. But there's another way we can do it. If you can power everything in under the root, okay, you can power everything under the root. So what I can do is root 6. I change the 10 to a root 10 t, and then I want to square it here like this. Okay, if you can understand that. So I'll make 10 to root 10, and then root 10 squared will still be 10. Now you have root 10 squared and t squared, which use the index law number 3 or number 3 or number 4. No, number 4. So you can combine that back. It's root 10 times t and then whole thing squared. So then from this result, what we'll say is root 10t, then bracket 2 over 6. Then I can do 2 over 6 now because you have power everything under the root. So that will be root 10t 1 on 3. So that's 2 answers. Doesn't matter. Like it doesn't really matter. This is just a practice to help you to understand how the root and then rational index works. Say this one is more straightforward. Like if you're not good at calculation, not good at algebra, I'll say the first one will be a safe way to do it. You can just see anything under with a root, that root must be 1 over the nth root. So it's easy here, but this one is use more laws inside, but it's easy to make a mistake as well. Okay, let's have a look at the next one. Okay, you can see the 4 is not the power for everything again. Okay, so not power for everything again. And also 8 is very hard to make into something to the power 4. Okay, 8 is 2 to the power 3. It's not going to become 2 to the power 4. So what I will do is 8m to the power 4, the everything with a root 1 on 8. But what I can do, okay, I can do something further. Just keep using the index law. Okay, keep using the index law. That can become, well, what is 8? 8 is 2 to the power of 3, right? 2 to the power of 3. So I can say that's 2 to the power of 3 bracket 1 over 8 times m to the power of 4 1 on 8. Okay, so I use the law ab to the power of m equals to a to the power of m times b to the power of m. Just separate those two. Separate, not necessary. Again, it's good to leave the answer in as the first line. I'm just trying to show you like more with how to calculate things. Okay, that's also something we could do. Then 2 will become 2 to the power of 3 over 8. Because I use a to the power of m, then to the power of n equals to a to the power of m times n. So I can further do that. And then m is to the power of a half. Because 4 over 8 is a half. So that's 2 to the power of 3 over 8 times m to the power of a half. Not necessary? Okay, it's not necessary. You can keep the answer in the first line. But what I'm doing here is just show you all the index laws, how to work through all these index laws by using fractional indices. Any questions? Okay, for the next one, well, you can see the 2 is not in the root or like not be powered. So the 2 just stay by itself. And you go to times with, yes? Yes, it's the most simplified form. 2 to the power of, okay, so g to the power of 3, h to the power of 5, and then to the power of a quarter. Again, I can expand that as well. That's 2g to the power of 3 over 4 times h to the power of 5 over 4. Just go that time power of a quarter, and then h to the power of 5 to the power of a quarter. And then use the index law again. We can times the two power together, which give you 3 over 4 and 5 over 4. And the 2 is a number not in the search, so I don't need to really worry about the 2. So 2, just keep it in the front. Okay, give you a minute to quickly go through example 2 here. Just go through example 2. Put that into the third form. So, for example, what is this? Okay, I'll just show you one example. 2 to the power of 3 over 4. I can say that's 2 to the power of 3 and then to the 4th root. Or I can say that's 2 to the root 4 and then that time to the power of 3. I can go for both ways, but maybe this one looks better. Maybe the first one looks better. Looks more simple, but like they're exactly the same. So I can go to the power first, or I can go for the root first. So use the same idea to complete the next 3. If you have done this example, you can try the next one. I will wait a couple of seconds and then go through the result with you. You can keep going with the rest. Okay, so let's have a look. Example 2. Example 2 is quite easy. We can say there's 3 to the power 4 to the 7th root. Or I can go the other way to 7th root and then to the power 4. Okay, next one. Next one is 1 over. Okay, even though you already have the 1 over, the fraction won't change. Okay, so the 1 over is just get rid of the negative sign here. That's 1 over 11 to the power of 1 on 10. And that is 1 over 10th root of 11. Okay, next one's the same. That is 1 over 7 to the power of 2 on 5. And that is 1 over 7 to the power of 2, then to the 5th root. Okay, so that's example 2. I'm going to skip example 3 because I think you can do example 3 later by yourself. But I want to go through some of the example 4 with you to let you get used to the calculation. I think you're not very good at like calculate other than square root. For example, the 4th root, 5th root. Maybe it's hard for you to think about. So let's have a look at the next one. Okay, this one is the one I mentioned. It's better to take the root first and then to the power 4. Think about 1 to 5. If you to the power 4 first, what the number will become? A really extremely large number, right? So we better do cube root 1 to 5 and then to the power 4. Because when you're trying to take the root of a number, normally we'll go to a smaller number. Okay, we'll normally go to a smaller number. What's the cube root of 1 to 5? 5. 5 times 5 times 5 gives you 1 to 5, so you have 3 5s inside. So one of the 5 will come out. So that's 5 to the power 4, and that is 6 to 5. Because it's 25 times 25, and that's 6 to 5. Okay, similarly, we can have that one. So we better take the root first. So that's a square root. I don't need to write the 2. So that's a square root. So it's same as when you put the 2 here. So it's a square root. And then we make it to the power 5. Then we make it to the power 5. Well, if you take square root, that's very obvious. That's 2 on 5. Then to the power 5. And that is... well, it can be too large to do. So 2 to the power 5 is a 32. Over, well, 5 to the power 5 is 6 to 5. And then times by a 5. 3, 1 to 5. You don't really need to expand it. If a number is really large, it's easy maybe to put into the power form. Okay, everyone can calculate what's 2 to the power 5. 2 over 5 to the power 5. So it's alright to leave the answer when it's really large to expand. Okay, next one can be a little bit tricky. So 16 to the power of negative 7 over 4. So that's one, well, I want to change it to the positive one first. We don't like negative indices, okay? So we'll change it to 1 over 16 to the power of 7 over 4. And then we'll have 1 over, okay, 4th root of 16, and then to the power of 7. What's the 4th root of 16? 2. So it's 2 times 2 times 2 times 2 give you 16. 4 2's repeated, 1 2 come out. So that's 2 to the power of 7. I'll leave the answer just like that. Not going to expand it. So I know that's 1 over some large number here. Well, it says if it says fully expand, then you go to simplify or evaluate. It's good to evaluate like that. Also in the test, like, it's not necessary to give you some number really large to calculate. It can just give you some number and test you the skill, like, which is easy to calculate. So I don't think I will put like some number like this too large for you to calculate in the test. So it's rather test the skill than like you manipulate with a lot of numbers. Okay, think about the negative number. Okay, what we all deal with is positive number here, and then let's think about the negative. So negative 27 to the power of a third. So that is a cube root of negative 27. Okay, what do you think that will be? Negative 3, that's right. Because negative 3 times negative 3 times negative 3 will give you negative 27. So when you want one of that, that will be negative 3. So same here. Negative 32 to the power to the 5th root. What that will be? negative 2, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 give you negative 32. So that will be negative 2. Let's have a look at the last one. This is the 12, negative 12 to the 4th root. What you can say about this question? Or what's the answer? Well, let's change 12 to a 16. 12 is not a good number, so I will change that to a 16. What do you think this will simplify to? Negative 2 means, which means 4 negative 2 times together give you negative 16. Is that possible?
It is a negative. Yeah. Plus or minus.
Plus. Well, like, doesn't matter if you take the plus. Like 4 2 times together give you what? Is that negative 16? Okay. 4 negative 2 times together give you what? Is that going to be no? So it's just undefined, this question. I'll just put this on purpose. It's not the wrong question. I just want you to see. Okay, let's see the difference between just these two questions I'm showing you on the board now. Why they all negative and they all have a root? Why one can be evaluated and the other one can't be evaluated? What's the problem? Like, why this one will be a negative 2, but that one can't be a negative 2? What makes the difference? An odd root. Okay, it's an odd root and that's an even root. Okay, odd root means, well, three number or 5 number or 7 number times together, you can have a negative number, right? But doesn't matter if it's positive or negative. If there's an even number of times together, it's always give you a positive number. So when you take a fourth root, means some number, four exact same number times together will give you negative 16, which is not achievable. Because if you have the same number times itself by 4 times, then it must be a positive number. Or 6 times, it must be a positive number. So it's not going to be the negative. So that's why when you have an even root of a negative number, it's not achievable. Yes? So that's why this question is undefined. This is a wrong question. Okay, basically, you don't have it. You don't have it. So that's a wrong question. So we will say that's undefined. When you have odd roots, well, it's quite relaxed. You can have positive or negative numbers. But when you have even root, you can only have positive numbers to put inside. Just very simple examples. Just you don't have square root negative 9, right? You don't have square root negative 9. That's because something times something, you can't have the negative. You must have the positive number. Okay, that's the evaluation here. The last thing I want you to look at is complete this table here. Okay, I give you 3 minutes to complete this table for me. Okay, so I will give you an example here. The first, well, the second line. Let's look at the second line. So 32, that's the third form. So if I put that into the power form, that's 32 to the power of a half. Simplification, if possible, can I simplify it? Square root 32. That's the 16. It's okay. Just disappear. That's the square root 16 times 2. And you will have a 4 root 2. I can simplify it. So the simplest form will be 4 root 2 in this case. So I want you to do the same thing for the other 4 column here. Okay, simplify it if possible, and then put into the search form or the index form as required. So 3 minutes to do that. Have a look. The first one I think is the one confuse you the most because that's the 9 and then a 9th root. Everyone trying to simplify it, or most of you trying to simplify it. Well, if you put that into the search form, that will be 9, the 9th root of 9. Okay, if you want to simplify something like this, you need to have a think, well, the 9th root, which means if I can simplify, there must be 9 things in 9 repeated factor in the third form. But for 9, I only have 3 and 3, right? That's only 2 repeated factors and there's no more. So I can't simplify it anymore. That's the end of it. Okay, that's the end of it. You can't simplify this anymore because you don't have 9 repeated factor. I can't drag anything out or I can't get rid of anything. So that's why I can't simplify it. Well, I have to go through the next one already. For this one, I would say that's a 27 to the power of 2 on 3 because the root is the denominator and the square is the numerator. So if I want to simplify that, like root 27 is a 3, that's 3 to the power of 2, and that gives you a 9. And that gives you a 9. Okay, this one, well, this one is very interesting because if I want to expand it in a way like the normal way, I would say that's 1 over cube root of 8 over 125. That's a fraction over a fraction. Okay, 1 over that. So, but this can be turned into 125 over 8 and of the root. Okay, this negative, just flip something. Okay, you can flip the fraction you have. So not necessarily write in the 1 over way. I can just flip the fraction and then to the power of a third. That's fine as well. So it's 125 over 8, then to the power of a third. So it's a cube root of 125 over 8. And then what you can simplify is, that is 125 of root 3 and 8 of root 3 of 8. Well, cube root of 8. So I will have 5 over 2 in this case. Okay, 5 over 2 in this case. Okay, the last one is just a 4th root of 256 over 625. Okay, and then I can say that's a 4th root of 256 over a 4th root of 625. Okay, what's the numerator will be? 4. Okay, 16 times 16 will give you 256. Okay, if you can see that, 256, you should remember some of the square numbers. At least the square number from 11 to 20. Okay, at least remember the square number of 11 to 20. So 11 square, 12 square, 13 square, 14 square, trying to remember those results, and it will be easy for you to do those questions. So if you can see 256 will be 16 times 16, if you know 16 square will be 256, then it's a 4. Okay, you have 4 times 4 times 4 times 4 give you 256. And then what's 625 to the power, like root 4? 5. 25 times 25 give you 625, so it's 5 times 5 times 5 times 5. So that's a 4 over 5. Okay, that's the end of this exercise. It's just put rational indices and combine negative together. Yes?
What about the question?
That's it. You can't simplify. Yeah. You can do 3 square, but that's not answer. Like, it's still not a simple answer. Like, you can do that. That's 3 to the power of 2 on 9. But still you don't know how large is that. What's the size of it? It's not really a simple form. You just another form of it. It's not necessarily simpler.